Greenhouse warming theory is rapidly becoming the most expensive mistake ever made in the history of science. Video 15. Why is science so important for informing sound public policy? Your survival, and especially your quality of life, are dependent on how well you turn lemons into lemonade, how well you anticipate, adapt to, and succeed in dealing with physical and social reality. Reality is what actually happens in life, whether you like it or not. Reality for a farmer is the number of bushels of grain sold times the price per bushel paid, minus all the costs of growing the grain. Reality for a regulation limiting air pollution is by how much the health and quality of life for those affected is actually improved, and by the number of premature deaths prevented each year. Reality in climate change is when, where, and by how much climate has changed throughout Earth history and how it actually changes in the future. Reality for a politician is the number of votes received. The ultimate reality for lovers is a baby. Science is the primary tool available to help us anticipate, estimate, and deal with reality in an informed way. The scientific method is simply the most logical, objective, and disciplined way we know of observing, understanding, and utilizing what is actually happening in the world around us, both physically and socially. The scientific method is also the most effective way for groups of people to work together in search of ultimate truth. Personal and group experience and training, informed by science, are our primary links between physical and social reality on the one hand, and what actions we decide to take as individuals, as social groups, as businesses, and as governments. Science has provided the foundation for all the technological advances that have improved our ways of life, our health, our wealth, and our happiness. As technology plays a larger and larger role in all aspects of our daily lives, we are becoming more and more dependent on science for informing our actions so that we can respond in the most effective ways. Unfortunately, a majority of people do not understand science, are intimidated by it, are fearful of it, or would just rather believe what they want to believe. Some are turned off by the mathematics. Artists are better at art because they have had extensive training and spent hours every day practicing their art. Similarly, musicians are better at music, lawyers are better at law, and scientists are better at science. But we all need to appreciate the value and importance of rational scientific thinking in today's increasingly technologically complex world. Scientists have a passionate desire to get it right, to separate fact from fiction, to separate reality from belief, to understand the reality of how things actually work in nature. The closest thing to truth in science is a clear observation of what is happening in nature, a clear observation of reality that does not require assumptions or theories to understand and replicate. Scientists are fallible humans. Some do their job better than others. Some are more curious than others. Most excel in detail. Some have a broader overview. Each has their own personal worldview. Each has their own political leaning. Each has their own religiosity. Each has their own prejudices. But what unites all scientists is the scientific method, which is simply the most logical way of thinking analytically, inquiring rationally, carefully weighing the evidence, seeking understanding in ways that can be tested, replicated, and potentially falsified. Most scientists are highly curious and as persistent as their work environment will allow. It is the scientific method, developed and applied over the past 500 years, that has led to the rapid growth in knowledge. This knowledge has allowed world population to increase by more than a factor of 13, while constantly improving food supply, quality of life, health, and robust global economies. Scientists try to determine cause by observing effects, to try to build upon current understanding by making detailed observations, hypothesizing causes, and proposing theories. As Carl Sagan, famous astronomer and science educator, said, There are many hypotheses in science which are wrong. That's perfectly all right. They're the aperture to finding out what's right. Science is a self-correcting process. To be accepted, new ideas must survive the most rigorous standards of evidence and scrutiny. Scientists are acutely aware of uncertainty as they build understanding on what is already known. They know, for example, that we have working models for light, heat, electrons, atoms, DNA, gravity, to name a few, that appear to explain most observations. They also know that these working models may be improved in the future by utilizing new observations and new insights. But all scientists know there is little in reality that is 100% certain, except for death and taxes. Conservative commentators like to emphasize uncertainty, that scientists are not sure about this or that. This shows a fundamental misunderstanding of the scientific method. Scientists seek perfection, but can only approach it step by step. Scientists, therefore, try hard to estimate their uncertainty, which allows users of scientific information to estimate how important a given conclusion is likely to be for them and to react accordingly. A good example is a weather forecast. There is a 30% chance that it'll rain in your neighborhood tomorrow, and the temperature high tomorrow will most likely be 70 degrees. Science is becoming more and more of a team effort, large groups of scientists working together with expensive equipment. New ideas, however, can easily be suffocated by groupthink. The digital revolution is making it easier for individuals to examine group data without group pressure. Remember, it was the instant availability of ice core data on the internet that got me started on the research and the revolution described in these videos. Science is not done by popular vote. Science is not done by consensus. Consensus is the stuff of politics, while debate is the stuff of science. Consensus among scientists is thought by many to reduce the estimated uncertainty, but it does not prove the conclusion is correct. As Michael Crichton put it, the greatest scientists in history are great precisely because they broke with the consensus. If greenhouse warming theory had turned out to be physically correct, this drive for consensus in order to spur political action would have been judged heroic by history. But this drive for consensus ended up derailing the scientific method. When scientists discovered potentially problematic data, they became more likely to try to rationalize the discrepancy rather than to question the theory. Debate is the stuff of science even when there is a very broad consensus that Earth is flat or Sun revolves around Earth. Scientists typically describe their observations, assumptions, theories, and conclusions in scientific papers that they usually send to their friends for review. Many employers require internal scientific review. Then scientists submit these papers to scientific journals whose editors send them out for review. Most scientists crave peer review to help them produce quality results and to be sure that they have explained their work as clearly as they can. Peer review works especially well for detailed studies where there are a handful of other scientists working in the same detailed field. Most scientists are specialists, and when reading papers outside of their specialty, like to know that at least some specialists in the paper's science have provided peer review. Unfortunately, peer review breaks down for broad papers that bring together information from several specialties. Most reviewers do not feel competent to review all the specialties involved. Even more problematic, peer review often breaks down for truly novel papers, especially when editors reject high-quality but controversial papers without sending them out for review. Science moves relentlessly forward, accumulating facts and theories. But as explained by Thomas Kuhn, science is typically punctuated by scientific revolutions. Times when new observations and new understanding lead to a major change in paradigm. Times when a widely accepted theory based on decades to centuries of scientific research and development is shown to be mistaken. Today we are in the midst of such a scientific revolution. Most scientists are not even aware of this revolution yet, as they cling defensively to well-established ideas. Yet this may be the greatest scientific revolution ever in world history when measured in terms of economic and political consequences. As explained in these videos, we've come to realize that our models of temperature and matter, heat, light, and electromagnetic radiation are not quite right. They do not properly address the reality that all are the result of a broad spectrum or continuum of frequencies of oscillation of the bonds holding matter together. As a result, we now recognize that greenhouse warming theory is not only mistaken, it is physically impossible. We also now recognize that the photon, which is central to quantum mechanics and particle physics, appears to be a mathematical convenience, not a physical reality. Widespread acceptance by scientists of these major changes in paradigms could take years to many decades, but in this case, time is of the essence. We do not have time to wait. World leaders are preparing to spend tens of trillions of dollars to reduce greenhouse emissions, an action we can now understand is likely to be a monumental waste of money. It is no longer clear that increases in greenhouse gas emissions have any significant effect on observed global warming. Plus, the global climate wars over greenhouse warming theory are ripping our political systems apart. Science is a living, breathing entity with a diversity of ideas, each at a different stage of development. Science is never settled. Thank you.